Hey, what's up, guys? Welcome back. So here we are for another session of the Python backend stacks playground. This is kind of turning into a project of, can artificial intelligence just build a building automation systems someday? Um, so we've been testing out here the last couple months, a lot to do with Python and the backend stacks. I think it's really friendly. That the Python backend stacks are really friendly for building automation technicians. It's easy to use library. The coding isn't too bad. We've been studying a little bit of theory, computer science theory, as well. Lots of vibe-coded apps that we've done along the way, including making a weather station that exposes BACnet objects to a building automation network for web weather data, which is actually like a real use case for building automation system. So we've been doing a lot and kind of using that building automation technician background level of what we know about building automation systems. We're usually technicians. We're deep into the weeds inside building mechanical systems, HVAC. Sometimes we work for mechanical contractors building a massive HVAC system that could run a hospital or a large school or some higher educational building or a big office. So we're building automation systems exist in big buildings. So we're PLC programmers. We do a lot with automating systems. So Python and computer science is one thing that we don't do very well. So I'm still want to get back into the lessons for the computer science. And we've left off in the algorithms. So I want to come back to that at some point. But there's just so much other material worth investigating. So I've been playing a lot with OpenClaw for some other projects. Some people use OpenClaw. Most likely there's some YouTuber scraping social media feeds and finding the latest and greatest project on hackernews.com, or something like that. No one's using it for smart buildings that I've seen. And it can do a lot of really cool stuff, including making, I'm playing around with, can OpenClaw make data models, knowledge graphs for building systems? And yes, it can. It's really good. So this stuff is really cool. So we've been doing some vibe code checkpoints. We saw a whole bunch of real basic Python scripts to read, write, priority array, backend servers. We've done that along the way. All the tools to set up VS Code. Check out the earlier videos. And I also tested if OpenClaw can start bootstrap Voltron even. So we've tested that out, and we're kind of all the way down to here. So I want to see if at some point in time, I think we'll be able to just drop this into some kind of AI tool, and there'll be enough context in all of this that it will just be able to make a building automation system. So what I mean by that is, like, there's typically an appliance, like a small computer running inside of a building that has a scheduling widget that we prototyped last week for some web app code for front end, HTML. That would be a scheduling widget for building automation. So they all have some kind of a generic weekly calendar widget where everything now is web app. So it's very rare, if at all anymore, if you'd see a building automation system that you don't dial into with a browser. And that's typically how it's probably been the last 10 years for sure. So AI is really good at making web apps, and so far that nothing has really changed in the build operation technology world for building systems like elevator systems, HVAC systems, which we're heavily involved with here, metering systems for energy, fire alarm, video, you name it. They're technology systems. They call them OT, It's the OT and the acronym IoT. OT systems haven't really changed much with the AI. That kind of has made every other industry kind of go upside down. It hasn't really, that I've seen, put a dent into the OT world at all. So we're still, but it'll come someday. And I have a feeling, maybe some of this stuff can kind of pave the way a little bit. At least I'm excited to do this. So coming from a former building automation technician, where people have told me, you'll just always be a field grunt, you'll always be climbing ladders and that's all you'll ever do. And I'm here to say, no, we can do cool stuff too, so you don't have to be an advanced computer software engineer person or PhD to build this stuff. You do just have to have, the most important thing is just the field knowledge of what makes a building go. And there's, I'm here to say there's probably not that much to it. It's just if you get a little familiar with building web applications, which there's been billion tutorials over the years of beginner level HTML, CSS, JavaScript, just a little bit of that knowledge and your field experience of being a building automation technician, you can just make it, I think, with AI here pretty quick. You can deploy, I want to demo this, well, we'll just deploy it on a Raspberry Pi, and you would have a JACE, basically. So to do that, we'll need this scheduling widget for equipment. We'll need to see sensor values for BACnet data, the HVAC system. I think we'll also need to build out a way to dial out. So in all these building automation systems, if a pump fails, if a fan fails, if it's a critical system, there's always some feature in there to connect to an email SMTP server and dial out to the maintenance staff that this fan or pump failed. These are all widget-based systems that they cost $5,000-$10,000 to set them up inside of a building, when we could probably just stick a Raspberry Pi out there and do it all for free. The Python libraries have everything you need to know and then some. There's a Python library for it, including BACnet, everything we need here. There's Python for it. The only thing Python can't do is it can't run in the browser. It's not a HTML. It's not a front-end library to make front-end web applications, but it is back-end. So there's a lot of back-end frameworks for Python, and Python is used pretty well in industry for back-end web development. Really good frameworks that has been around for decades. One of them is called Flask, one of them is called Django. Another one is called Fast API. I'll show you here in a second. Voltron also uses that's all Python-based platform, and it is also did some Python web application hosting, the GUI that OpenClaw made. Okay, so where should we go with this? So that's what we're going to try and do today is start this. I have a feeling it might take a couple of videos to build this. Eventually, we'll get to the Rust BACnet stack. That's the new kid on the block. Eventually, some Wireshark, Linux, BACnet traffic on the wire. We should get into one thing to note that the Voltron work, we used a Linux service called systemd. That is just a keep that in the memory bank. It's like a service built inside the Linux operating system. You can deploy a Python script or a Python application and let it run long term, where if the computer reboots, systemd makes sure it comes back up. And then we can also do this with Docker. I think Docker is a lot easier too. And some people even prefer Docker a lot more than systemd. But when we set up Voltron, this was all systemd. And then we're going to start using Docker here. So, okay, so where should we get into this? We'll go back to algorithms someday, so maybe I'll just close this. We got vibe. So last time we just vibe coded our vanilla JavaScript front end, and here's a Docker file, and so AI built this. I think I did it in Cursor AI agents last time, and then we chatted with it. We want to use Flask. Please use the vanilla JavaScript. That means that it was just plain vanilla, like a plain vanilla ice cream cone must be where it came from. No extra nothing. So it's just plain JavaScript that it is trying to give us, because there's like Python, there's a million different libraries that JavaScript also has too, but vanilla JavaScript and vanilla Python or vanilla anything is just, right from the foundry, basically, of where plain Python, plain JavaScript. So that's why we're kind of just maybe going that direction of just maybe starting with this. And then there's also a one for React, and this is like a really advanced front-end web development framework, where if you were like a really experienced web app developer, you would probably be doing stuff in React, but we're just going to do stuff in vanilla JavaScript for now, just because it's probably easier to start with, and then maybe we can build this into having both. So where is I going to start with this? Let's just go. So this is the app code that will Flask library. So this is just a little bit of the backend web code. I'm just kind of studying in here. I didn't even look at it. So probably not too much different than the other stuff we've been looking at before. So this is like a backend function here, where it's going to serve our HTML file. So that's what backend web app development code does. It just, when you dial into a web app, there's going to be some function running in the backend that'll serve you static files. There's a little API here. So I'm curious to see what this will do. I have a feeling this will be a couple different videos just getting this to work. But let's just start with, I know what I wanted to show you guys. So like, I did have just a little chart here, draw.io. Hopefully it works. Brings up here. Okay, so we were kind of making a little from recent vibe code app 8. Okay, so this is on the BAS Pi. So like, I'm going to use VS Code right here, and I'm going to be on my Windows computer, which is on the same test LAN as the Raspberry Pis. I'm going to be using SSH, which we've showed a little bit before. That's secure shell. I can dial into the BAS Pi, like the Linux command prompt. But I'm going to be running VS Code here. That's right here, actually. And then we're going to be dialing into the BAS Pi directly. And then I want to see if I can at least set up, this is another app of mine called the do-it-yourself diy-bacnet-server. So maybe I can just demo this today, but it kind of has all of the functionalities of backpipes built into it. And it's all like a modern asynchronous framework. And then eventually we'll be serving this front end. We'll be running 2 Docker containers, one for the Flask app that'll serve this front end, and there'll be a scrape interval for our there'll be backnet devices down here too. So that's kind of how it'll work. There'll be 2 Docker containers. Just try and keep that in mind, how that'll work. So let's try and get this one at least running today, and then if I have I can go up to the top of the hour for my lunch hour, and then let's maybe see if we can get this running. I think it'd be, what I also want to do too is potentially get OpenClaw running here. So there'll be a 3rd Docker container called for OpenClaw. Okay, so let's I might actually just do this first, like Docker, just Google it, Docker, Linux, install OpenClaw. Needs about 2 gigs of RAM. Alright, let's just run this. I'm just gonna copy this. This looks about right. Yeah, why not? Let's just do this. Okay, so this is just a command. Anyone that's familiar with Raspberry Pis, it's just running some updates here. Hopefully it's the size is okay. Let's see if I can zoom in just a teeny bit more. Right here, so there should be another zoom in feature. Okay, so it's just running some updates. So this is just installing all of the packages to do run some updates. Pretty typical. So this is VS Code. So right in here I have the Explorer open, which is this little window, and I'm using this remote Explorer feature. So like I have this is running on my Windows computer, and then I'm remote explored into the Raspberry Pi, and I can see all the files in the Raspberry Pi. I have a fake Modbus device that I use AI to create to mimic an energy meter for something else I was playing around with. Alright, so this might take some time to run all this, but you can also open up another window here. Let's do a new terminal. So I have 2 terminals open here, not 2. I can't remember if I have tmux open or not. Nope. Okay, so what I kind of want to definitely show you guys today is like, this is from one of the earlier tutorials when we did the mini calendar schedule device. So this is on the Raspberry Pi. This will just basically be a refresher from some of our older vibe coding. So I'm just going to enable a virtual environment in Python, which we've done before. I have to cd into this virtual environment here, virtual env, and then I could do a .env bin activate. So this is a virtual environment in Python, and then I already did the pip install, backpipes 3, which we've done before, and the networking package called ifiter. So I did this already, but I'll just demonstrate it again. And then sometimes if you get that, I think you can do python-m pip install backpipes 3 and if header. For whatever reason, it did not like. Sometimes it makes you specify Python 3. There's a Python 2, which is really old and outdated, and it's still giving me that. So maybe we'll just deactivate this. And then I'm just going to do python-m vmv env. I might just delete these. And if it does not like this, then we'll just use AI to help us out. I think AI is really good at helping people with the proper Linux commands. One thing you can also do is use a desktop environment. So if you wanted to use the desktop environment, it's imaging your Raspberry Pi to have a full-blown desktop, which is a lot of heavy lifting for the Raspberry Pi, so it'll consume a ton of resources and memory. So I'm doing the light Raspberry Pi image, and the only thing you can do is just the command prompt to free up more resources, because try and do that if you're kind of new to all this. I've definitely used the Python or the Raspberry Pi desktop for years and years and years, but try and get used to just using terminal only in Bash. Okay, so that worked. So we have a new virtual environment. I'm going to try this again. For some reason it didn't like that. .bnv activate, and then you should just do pip install backpipes 3 and if editor. Okay, so now it's going to download these two environments. Okay, so it successfully installed that, and then we're going to be playing around with this, the fake. Actually, I just realized something. Maybe we'll end up playing around with something else. What do we got here? Looks like they're saying some libraries are outdated, restarting some services. Okay, so I still wanted to, this is going to clone OpenClaw. Sorry about that. So like, I actually, so this is our mini calendar script that we made a long time ago, where we were making a backend point for schedules. So this is a scheduling backend point where it worked pretty good. And then we'll actually install this DIY. Just gonna deactivate this. The diy-bacnet-server. So I'm gonna try and do two things at once here. I'm gonna see if I can get OpenClaw set up and do this at the same time. So this is GitHub. This is my GitHub account. I'm gonna try this, copy. I'm just gonna do, so I have Git installed on this computer. So Git clone. And then we'll also be doing, back on here. Okay, so this is still cloning OpenClaw. So that must be a really big project. So right now I am in, we just cloned the diy-bacnet-server and OpenClaw. So while OpenClaw is still running, let's see if we can fire up the diy-bacnet-server. So this is a project that's kind of cool. It has this web app framework called Fast API. It has a GUI that you can test all this stuff. So we can do all the things we've done before. We can do client read, write, read multiple, whois, point discovery, supervisory logic checks, read priority array. So you can do a lot of stuff right through a little browser here. A couple Modbus features I've added to it recently. Okay, so yeah, so we did this step right here. This is the important thing we want to kind of verify. Okay, so this is why I did that. Okay, so let's get back into, we need to get back into virtual environment for backpipes. So I'm going to cd back into virtual env and do this again. Sorry about that. Okay, so now that we have this virtual environment open and we pip installed backpipes, what I have as a prerequisite here is like you can open up, we've tested this once in this earlier tutorials, backpipes 3 has a shell inside of it too. so you can open up the Backpipe shell. So we're just going to open up the source code of Backpipes, and you can actually run a few commands through the shell of Backpipe, so it's actually pretty cool. So in here, there's some Python scripts, but we're not using it. We're using Python scripts that are inside the virtual environment, which has Backpipes reinstalled. Okay, so let's just try and run these. All right, so we have the shell opened up for Backpipes, and I just wanted to do a whois. Whoops, whois. All right, so now we're running the whois, and we have one device responding. I think, yeah, one device. Well, I think there should be two. Looks kind of odd. Because if I run, okay, so now I'm going to run this from my Windows computer and just confirm that. So this is running. So this is running on the Windows computer. For some reason it's only picking up this device, but there's definitely two other ones. Okay, so if you can see that, when we did this on my Windows computer, it's actually, I can see it through here. But it's only picking up this one. I don't know why it's not picking up the other one. Seems a little bit unusual. Well, anyways, so that's kind of like a prerequisite that you can see BACnet devices. And maybe let's just dive right into Docker. This is a couple notes on how to get a firewall set up. Okay, so let's just, I'm actually going to run this, but maybe modify it a little bit. So maybe I'll just put a new file in here. It's notes.txt. Okay, so this command will change directory into here, and then this is also going to create an environmental variable file called a .env. It's going to use Docker to build the diy-bacnet-server. And maybe let's change our BACnet instance ID. And then we need this to run on .12, I think. Let's do it. You can do in Linux IPA. Yeah, .12. Is there IP address? Alright, so I'm just going to try and drop this command right into the command prompt. Actually, I should be able to deactivate all of this. No diy-bacnet-server. Oop, never found it. Well, maybe we can just try this directly. Oof. Okay, change directory, diy-bacnet-server. So one thing I forgot to say is I do have Docker installed on this already too, which isn't too hard to do on Raspberry Pi. You just have to run a couple commands to install Docker. Just a couple commands like we did now, like not too different than the commands I did when how to install OpenClaw. You just do one for Docker. Speaking of which, this is our next command to install OpenClaw. Okay, so it looks like OpenClaw is ready. So we can do both of these builds at the same time. let's do get OpenClaw set up on the Raspberry Pi. So right now it's building its Docker image for OpenClaw. I'm going to switch back to the other bash session. So now it's building the DIY Docker at the same time. So this is like an older Raspberry Pi. It's like a B+ model. It does make me think here. So like when we're on here, not super used to these draw.io, but I guess it'll work. Probably good enough. So I probably should put like some IP address information on here. I'm just going to do some of this while the other stuff takes some time to build. This is 204.11. Make the font a little smaller than the BAS Pi. Let's see, what is this, 12, I think. So this is just my little local area network for my test bench. Not too terribly different than the real world. Okay, so then what we could do here, this will be the third Docker container. Copy, paste. And this will be OpenClaw AI. Actually, maybe we should make that OpenClaw AI. All right, so I just thought about this. So like when I use OpenClaw, so these are in little Docker containers. So like there's actually what's going on here is that so these are Docker containers. They're actually little Linux images inside a Docker container. So there's actually, so this is a host. We should probably put a note in here. Oh, where did it go? Stupid thing. So we should probably say host OS Raspbian Linux. And then this is actually a little Linux image in here, Ubuntu Slim images. So keep that in mind. This host operating system is Raspbian Linux. And then there's Ubuntu Slims in here, I think. Let's see if we're done. Okay, cool. So this is running already. So the DIY Docker server is running. Okay, so this failed. Wow, okay, maybe you can't install OpenClaw on Raspberry Pi. I've had some issues where this Raspberry Pi is too old. It's an old B+ model. And it's saying that like a cursor, my AI coding utility said that architecture not supported. That's a bummer. But maybe we can just keep on continuing through this. Of course, I don't even have maybe we forgot this up. One thing I did do was just went to Google instead of going to the OpenClaw website, so maybe that had something to do with it. Let's try it one more time. I have a feeling this this Raspberry Pi might be too old. Let's try it one more time. Yeah, I have a feeling the same thing I've noticed for cursor too. It did not like that ARM version 7, whatever that is. Oh shoot, I think we might just give up on this. So I might just delete this then. I do sudo rm r. I think I do sudo -rm remove OpenClaw. rm-r OpenClaw. Kind of a bummer, but oh well, is what it is. All right, so at least we have the DIY Docker container running. Let's dial into it. So I should be able to do, so this guy was IPA. So that's the 192.168.12. This is where we're running on. Let's see if we can just dial into you. Let's see, so we need to do .12. I'm going to port. Okay, so we have to just dial into a port here for our web apps, which we'll get into all this fancy stuff a little bit later. Okay, so this is the diy-bacnet-server running on our Raspberry Pi that we just loaded. So let's do a whois from here. These are kind of cool. So this like little interface is called Swagger, and it's meant for backend web app testing. So it does have a feature where you can do a request for backend instance IDs, which we're all pretty used to as building automation technicians. We can execute it, but we still have to authorize this. So I might just close that bash session and then just get into this one. Okay, so there's just like a one security feature that I have added. This is like a bearer token. It's a security key to make our app have a little bit of security here. So like when you bootstrap this app, it comes with this .env file, and then you just have to paste this into the browser just so we're authorized to use this. There's just a teeny bit of security I think is kind of important. So now we can do a backnet whois through here. Okay, so this is working, right? So we have device 3456790 9.89 which should match exactly what we're doing on our Windows thing too. So when we run this on our Windows, this should match over here. See, ta-da. Okay, so this is kind of a cool tool. Like you can do point discovery. So if we wanted to do point discovery, try it out. Let's do this device. And this is all the same code. Actually, these are all of our backnet points, commandable. You kind of have to do it in JSON format. Execute a point discovery on our fake air handling unit. So these are the same devices that I've been previously working, that we've been previously making some scripts for. So this is the diy-bacnet-server. And then you can also do supervisory level override checks. This is something that someone else requested. So it's going on under the hood. It's actually does a point discover, and then for each point it for loops, and it finds if a value is overridden at all. Pretty cool. If anyone wants to play around with this, I think it's kind of fun. Hopefully that makes sense. So this is the diy-bacnet-server. You can do read priority array. So we've done all of these scripts by hand. Before, and then all of these scripts are just basically running in the back end of a web app, and the web app is the fast API framework, and that's what gives us this kind of cool browser this browser interface. If you ever wanted to actually see what the code looks like, if you go into, there's Modbus features, MQTT, which I'm still working on. So basically, in some variant, all of the Backpipes 3 scripts that we've been working on exist in the back end somewhere of this web application. So it's you would almost kind of recognize it if you're familiar with these code bases. One thing else that is kind of cool about this tool is the diy-bacnet-server is that there is what you do is you define your backend server points. Like when we did our backend server for the web weather, relative humidity, and dew point, we manually coded that in our Python script, but here you just define it in a CSV file format. And I also have by default an occupancy schedule, a Boolean point. And then there's also a schedule point, which is, this will be something that we'll play around with when we how we have our front end vanilla JavaScript for the weekly scheduling widget. So we'll be hitting the back end of the diy-bacnet-server on this point. So that's my goal. We haven't made it yet, but the idea is that no, we have to change this already because that didn't work. So our Flask will actually serve our HTML, and then it'll hit this the diy-bacnet-server, and these two services will talk back and forth via JSON RPC to each other. So they'll kind of talk back and forth internally, and then we'll be talking back and forth here. So the Flask app will serve us this HTML file, and then the HTML file will actually be writing here, and then under the hood, these two apps will be talking back and forth. And then we can also validate that it's working through here. Okay, so where should we go with this? So like what I want to do, one more note on this is like a primitive variant of this. I did have a friend that used this as a backnet gateway for a chiller plant, where he was talking Modbus to the chillers, and he's a Node-RED expert. He did all this in Node-RED through Modbus RTU, and then he needed a backnet gateway for the building. So we use this, a primitive variant of this app, to do a Modbus to backnet gateway, where this is his chiller plant, and he populated all these values in by Node-RED, making requests to the diy-bacnet-server. So he would populate all of the sensor data that the chiller was doing all of the all this stuff is probably 100 more points if I remember correctly. And then the building automation system had one or two writable, commandable points. So we would actually read that data back into the diy-bacnet-server. I can't remember where it is. So I know for a fact there was one, yeah, so a chiller enable. So I think the building automation system scheduled the chiller plant with a scheduling widget, which we're making, and then we would read that data into the diy-bacnet app and pass that to Node-RED, and then back and forth. So if anyone is interested in this application, I could make a better demonstration of it, but this is a really good gateway for that application. And then I'm also using it internally as a microservice with Docker. Okay, so we'll get out of this. This is the Raspberry Pi. We're dialed into this right here. I should just put this on here somewhere. Maybe I'll just throw this right there. Ooh, too big. Or else I could just make this a little bit bigger. So we could trim you down to I'll probably fix this a little bit. Not really used to this draw IO program, so I apologize for that. But this is the diy-bacnet-server, and yeah, I'll try and get this a little bit more pretty, but we can dial directly into this Docker container via port 8080 right into the Swagger here. And then this guy will also have the same IP address, but the Flask app will operate on a different port. Hopefully this makes sense. I think I might stop here, guys. But like, one thing that I wanted to show you, perhaps, might have to wait for the next YouTube video for this. So like, on a really old Vibecode app, when we were playing around with these, how to read a scheduling object. Maybe I'll do this real quick. So right now I'm back on the Windows computer, just opening VS Code, and I just want to prove that I can hit the Raspberry Pi. Okay, so if I go here, just one quick thing before we head out here. Let me just zoom in a little bit. So this is our so this is Vibecode app 4 when we did our open weather map, our open weather mini scheduling calendar device. So now we can read a scheduling widget. So let's just see if this will work against the Raspberry Pi, the DIY Docker container. Okay, so hopefully this makes sense. If I go back to here, so right now I'm opened up on here on my Windows computer, and then I want to hit the DIY Docker container that's running BACnet server that has the schedule object defined. So I'm just going to go from here to here and then see if I can read that in. So I have two sessions of VS Code open. The one on the left, this guy, is SSH into here, and then the one here is just running PowerShell right here. So what I need to do, I think, is change this to .12. And I think this should work. so it did work. So this did read against the Raspberry Pi. Remember, we set it up as device 9999. So it found the scheduling point that was inside of our DIY Docker container. Sorry that I'm jumping around all over the place. So it found this. So when I ran this on PowerShell, it found the DIY Docker container service running the BACnet schedule. Okay, and then like what we should play around with is let's change it on the DIY Docker container and just make a test. So right now it just has these very generic Monday through Friday, 8 to 5 schedules. So let's just change Wednesdays to how about 11, 11, 11, 11. Make it very obvious. So if I just go back, I'm gonna quit out of here, and then I want to, okay, so I think we might have to reauthorize. No, we're authorized, so we can actually read the schedule value. Try it out. Pass in our bearer token for authorization. So okay, so this is our schedule. All right, so then what I'm going to do here is I'm going to update the schedule. Try it out. So I wanted to go to, this is not very intuitive, but this would be Monday, Tuesday, Wednesday. So I should be able to go to 11:11. Let's just see if this works. 11:11 on Wednesday. Execute. And then we updated this point. Okay, so like, hopefully this makes sense. This is all what I did here. So I'm on here, dialed into the web app, served me the HTML, and then I'm just setting via the Swagger, the building automation scheduling point. And then I want to test that I can read it through BACnet. So I set that via HTML, and then it was like, it actually just does like a JSON RPC request, REST API, and then we're going to test that it updated in BACnet appropriately. Let's do it again from PowerShell. And it worked. Oh, that was Tuesday actually. So I accidentally updated Tuesday to 11:11, but so hopefully that makes sense, guys. We did this without a GUI. We updated the BACnet server point to reflect a schedule that we wanted. So when we get into this, it's getting really complicated. We'll be able to do this with our front end JavaScript. We'll be able to adjust our building automation schedule. Hopefully that makes sense. I'm sorry if this video is jumping all over the place, and this one might actually take more than a few days to demo, but hopefully you're liking it and following along. Talk to you later.